Ladies and gentlemen, hello. My student in Physics 4B, 3 sections, Tuesday 2 to 5, Wednesday 11 to 2, and Thursday 2 to 5. And also my evening section, uh, Monday, Wednesday 5 to 10, yes. Okay, so I know that I finished chapter 26. It was all about Ohm's law, about circuit. So I'm going to start chapter 27. It's about circuits. Chapter 26 was about electric currents and Ohm's law and power of resistor, and also consumed energy and how can we find price of consumed energy by kilowatt hours. So today in chapter 27, which I can tell you it's very important chapter. The reason is it's about circuits, and the people, the students who they want to be actually electric engineers, electronic engineers, even computer engineers. Overall, this chapter is very important because it's foundation of circuits. So whatever you learn in this chapter, you will use it in all upper division classes in university. So it is important. The first topic, which I can go over that in chapter 27, which it is very important, it's called Kirchhoff circuit laws. Kirchhoff, he was a German physicist. In 1845, he made two important laws in electricity about the circuits, and also he made three important laws in optic about spectrophotometry. Whatever he did in part of circuits, he opened the way actually for Ohm's law. And after Ohm, James Clerk Maxwell, which is very famous by his equations, which is called Maxwell equations. So that's why he did very important things in part of circuits in the physics. So now, I'm sorry, excuse me. So what is first law? It says, also it's called the law of junctions or junction. It says total input currents into a node or junction is equal to total output currents from that junction. What is that? This law in reality is the law of conservation. Conservation of what? You tell me. Energy, momentum, mass, which one? The law of conservation of electric charge, which I explained it last week in chapter 26. So it says total input to a junction is equal with total output from that junction. What is junction? Look guys, imagine here you do have a circuit. This is resistor. Let's say this is also resistor. So let's say this is R1, this is R2, this is R3. Okay? This point, it's called node or junction. Or what? Junction. I like to call it junction. So if you have at the point more than two wires, see this is wire number one, this is wire number two. If you have more than two, so this is three, then that point is called what? Junction. If you have something like this is not junction. This point is not junction. Why? Because this is same as this. There is nothing here. There is no any node. But whenever you have something like this, correct? This point, let me show it by blue color. You may like blue. So this point is junction. Okay? So now you know what is junction means. So imagine here I have a tube or water pipe, and then this water pipe subdivides to three sections. So what I am going to have here, let me do by different color. Watch guys. This is input, correct? Then these three are what? Outputs. So this point, it's called junction. It's called what? Junction. Therefore, your total input, let's call it the red one, it's I. Let's call it I1. I1 will be equal with what? With I2 plus I3 plus I4. Let's call this one I2, this one is I3, and this one is what? I4. And in the same time, this input is I1. So what I see here, I see total input is equal with total output. So this is called the law of junction. Total input current to a junction is equal with total output current from that junction. Alright? So in the circuits, if we have something like this, we can say, okay, it's up to you what direction you want to choose. So let's say this is I1. Then I'm going to say this is I2, correct? You can see I1 goes, I2 goes. So I1 is input, I2 is input. Then like this is river, this is another river. So two river, they join together, they flow in this way, correct? In third channel. So if this is I1, this I2, this will be what? I3. Now if I write junction law for this picture, what can I do? I can say I1 is input, I2 is input, correct? I1 plus I2 is total. That is equal with what? Your output, which is I3. Did you get this? For example, if I want to write for this thing, say this becomes 3 sections, correct? Let's say this is I1. Let's say this is, excuse me, I2. Then these are output, I3, I4, I5, correct? What can I write for this picture? I can say my total input I1 plus I2 is equal with my total output I4 plus what? I5. Why it doesn't write here? I5, there you go. Okay? So this is called the first law of Kirchhoff, or Kirchhoff's first law, which is called the law of circuits. Now let's see what is second law. Second law, it says this. It's called also the law of voltage. It's called also the law of voltage. Watch guys, it says total voltage in a closed circuit. Pay attention, total voltage in a closed circuit is 0. What does closed circuit means? Look. Let's say this is R1. This is voltage 1. This is R2. Is this circuit closed? What is the answer? No. Why not? Because I see it's not closed. Correct? So I see this circuit is not closed because it's open from this side. Oh, okay. Let's close it. Now it's closed circuit. We close the circuit completely. So what it says total voltage in a closed loop is 0. Yes. Look guys, how many components, how many electric components do you see in the circuit? I will say 3. What is that? One is R1, one is R2, because resistor is electric device, electric component. And the other one is voltage. It's the battery, correct? So let me say it's delta V. So we have 3 electric components. Therefore, when it says total voltage in the closed circuit, so how many components do we have? We have a battery, we have a resistor 2, we have resistor 1. So this picture tells me that total voltage across battery, so B means is battery, okay, plus total voltage across what? Resistor 1, plus total voltage across what? Resistor 2 is equal with 0. This is this. Sigma delta VI, that means is voltage 1 plus voltage of component 2 plus voltage of component 3 plus voltage of component 4 plus to the end, this is equal 0. This is called Kirchhoff's second law. Do not forget it. It's very important. You might have in one circuit battery, correct? This is positive, this is negative. You might have resistor, correct? You may have another battery, correct? You might have capacitor here, correct? And then we might have another resistor here. So I'm going to call this one battery for voltage 1. Second battery gives you V2, correct? This is resistor 2. This is capacitor. So for this picture, I can get what? I can get this. Voltage for first battery plus voltage of resistor 1 plus voltage of battery, second battery, plus voltage of capacitor plus voltage of resistor 2 is equal what? 0. This is called the second law of Kirchhoff's second law in the circuits. Total voltage in one closed circuit is 0. Total voltage in one closed circuit is equal what? 0. Excuse me. So far makes sense? Okay. Now guys, I want to do one example, then you will see how important it is. Okay? Remember, uh, let's do one example. Question says, below circuit, find current, so this is our goal, goes through each resistor. Below figure, find current goes through each resistor. Okay. Let's say we have, let me erase my whiteboard. Let's say we have a battery. This is positive, this is negative. Oh my goodness. Let me redo it. This is positive, this is negative. This is resistor 1, correct? Then this is another battery. Positive, negative. Come on. Okay. There you go. So let's say we have R1, R2, and R3. We have 3 resistors. Here we have voltage 1, which, let's say, voltage 1 is 20 volt. This is positive, this is negative. Here the second voltage is 10 volt. Voltage 3 is, let's say, is 5 volt. Okay? Let's say resistor 2 is 2 ohm. Resistor 1 is 1 ohm. And resistance 3 is 3 ohm. Okay? So question is, below circuit, find current goes through each resistor. Okay, what we have to do? First of all, you have to verify junctions. How many junctions do I see in this circuit? How many loops do I see in this circuit? I see two loops. One loop, two loops. Correct? So I can say this point and this point, they are actually junctions. Okay, they are actually one junction. Yes, if they are junction, therefore we do have electric current goes through each branch. How many branches do I have? One branch, so this is branch, look guys, one branch is from this point, goes to this point. This is a branch one. One branch is from this point to this point, red to red. One branch is start from here, goes to this point. So I do have three branches. Therefore, I am going to have three electric currents, I1, I2, I3. Now it's up to you. You are free in choice which one you want to choose I1, which one you want to choose I2, which one you want to choose I3, and in what direction. So then guys, I go by blue. I will say, it's up to you. If this is junction, correct? So this point is same as this point. So I can say, you know what? Oops. Oh. I will say, okay, I'm going to say this is I1, correct? Then this is I2, correct? So if this is I1, I2, then water flows into this branch, I3. Maybe maybe another student, he tells me this. No, this is junction, correct? I will say this is I3, this is I1, then I2 will be what? Will be this, correct? For this one, I can write I1 plus I3 is equal with what? I2. And for this one, I can write I1 plus I2 equal what? I3. This is up to you. Anything you want, any direction, any name you want to give for branches is up to you. At the end, for sure, all the currents will be same. Doesn't matter which one you choose I1, which one you choose I2, which one you choose I3. What is your junction and what direction they are. They will be same. So let's say, okay, I will say this is I1. That's just arbitrary decision. Then let's pick this one I2. Okay. If I1 is this, I2 is this, then what is this one then? Will be I3, correct? Okay. So I picked these purple colors, I1, I2, I3. So I can write the law of junction. Let me write it. You tell me it will be what? Total input. So it will be I1 plus I2 is input to that junction is equal what? I3. This is the law of junction. So far makes sense? Now, the next step, which I want you to pay attention on this section, please, guys. Label all points and junctions by English letters. So I will say this is A, this point is B, this point is C, all points, the corners, junctions, A, B, C, D, this point is E, not good, E, let me see, okay, this point is E, A, B, C, D, E, let's say this point is F. Okay, now guys, how many loops do you see in this circuit, in this picture, in this diagram? I can tell you it's two. One loop, closed loop, is A, B, E, F, A. One is B, C, D, E, B. Okay, so one is A, B, E, F, A. One is A, B, E, F, A. So I'm going to write it A, B, E, F, A. This is circuit number one. Correct? What is the second one? I can say it's B, C, D, E, B. Or E, D, C, B, E. Again, it's up to you. So, as I said, what do you want? I can say B, E, D, C, B. Pay attention. Close it. Watch. Don't say B, E, D, C. Done. No. B, E, D, C, B. Close it. B to B. A to A. A, B, E, F, A. The second law says total voltage in a closed circuit is zero. Do not forget this, all right? Therefore, what I can do, so I am going to write what? Sigma voltage is zero for each circuit. For each circuit, pay attention. Guys, I will start to go from A to B, then from B to E, then from E to F, then from F to A. So I'm going to write that. Okay, let's do it. So, let's start it. When I go from A to B, okay, let's go. I1 belongs on this branch. I1 is everywhere. Pay attention. I1 here is I1 also. I1 is here too. This is I1 too. Correct? I3 belongs on this branch and I2 belongs on this branch. So I2 is here also. I2 is here also. So please pay attention. And B is junction. Point B is junction. And E is junction. Doesn't matter. It will be same. So what I have, I1 plus I2 equal I3. I wrote it. Now I am going to write sigma delta Vi equals 0. I'm going to start for each loop. A, B, E, F, A. Let's start it. Go from A to B. I go. Go, 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 go. Oh, what is this one? Resistor. What is resistor? Consumer. Consumer eats energy. Consumer eats electric current. Consumer consumes. It gets hot, drops voltage. So resistor drops voltage. So when you go from A to B, your voltage decreases. Therefore, when we say voltage decreases, when we go from A to B, pay attention, I am going, and you know this, Ohm's law. What is Ohm's law? V equal Ri. So what is the voltage of resistor? Ri. What is the voltage of resistor? It's Ri. Therefore, I can write this. Voltage of R1, go, plus voltage of battery, plus voltage of resistor 2, correct? Plus voltage of first battery is 0. Watch it. So in the first loop, how many components do I have? 1, 2, 3, 4. As I said, total voltage is 0. So the voltage of R1 plus voltage of the second component, which is battery, plus the voltage of third component, which is R2, plus the voltage of first component, which is, fourth component, which is battery, is 0. That's why I have this. Then pay attention here. This is the most important section. As I said, resistor is consumer. Resistor drops voltage. What is drop means? Negative. Drop means is minus. So what is the voltage of resistors? It's Ri. Therefore, let's go A to B, A to B, A to B. Ask this question. See, I go from A to B. My path is A, B, E, F, A. My path is A, B, E, F, A. Okay. I go from A to B. Watch it. A to B. Ask this question. Am I going? Listen. Am I going in the same direction? Am I going? I go from A to B in the same direction. I go this direction. Am I going in the same direction as what? As I1 is? Yes. See? Am I going in the same direction as I1 is? I go from A to B. I1 is also in the same direction as AB is. Yes. If yes, drops voltage. It is minus R1, I1. I don't like writing by this pen, but so I'm going to have R1, I1. Oops, sorry. Okay. Minus. So am I going in the same direction? I go from A to B. Am I going in the same direction as I1 is? Yes. Because yes, it's minus R1, I1. Now, you go from B to E. Pay attention. Go. Go, 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 go. Now, I meet a battery. When we reach battery, guys, you don't need to care what is direction of current. Just look at this. If you go from positive to negative, your voltage here is negative. So it will be minus what? V2. If you go from positive, I go from B to E. B to E is from positive to negative, correct? From positive to negative, what is the second pole? Always second pole. It's negative. Will be negative. If second pole would be positive, this would be positive, remember. So let's go. BE. Go, 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 go. Oh, what is this one? It's battery. Hey, what is the second pole that you meet it? It's negative. So this will be minus. Voltage of battery 2 is V2, correct? Okay. Now, I'm done with BE. Now go EF. Go. Go, 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 go. Oh, what is this one? Resistor. Ask this question. Am I going in the same direction? See, am I going? I go from E to F. Am I going in the same direction as I1 is, as this purple one is? I go this direction, correct? And also, sorry, let me do this. Can you see me? There you go. Both it is in the same direction, correct? I go from E to F. I1 also is in that direction. Yes, the answer is minus R2 I1. Correct? Now go. Go, 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 go. I am reaching to the battery. See, I go from F to A. Go. Battery doesn't matter what is direction of I. Battery cares about what is the second pole. Go F to A. Oh, what is this? Positive. The second pole is positive, so this will be plus V1 equal what? Done. I reach to point A. Done. See, A, B, E, F, A. A, B, E, F, A. This is equal 0. Done. Let me correct this one. Okay, that's fine. This is for the first circuit. Now let me go on second circuit. I go with black color. Second circuit is this. B, what is that? BE, I choose BE. BE, doesn't matter, you can go B, C, D, E, B here, nothing changed. So let's go. B, E, D, C, B. Okay, let's go. BE. I3 belongs on this branch. Let's go. Go, 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 go. Oh, in branch BE, what I see? Battery. Okay, so I'm gonna have voltage of battery plus BED. ED. Go nothing. There is nothing here, it's just wire. Then go up, go, go, go. Oh, this is battery, so I'm gonna have voltage of battery 3 equal. No, 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 sorry. Not yet equal. Then go, 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 nothing, nothing, nothing. Go from C to B, go, go, go. Oh, what is this one? Resistor. Ask this question. Remember, am I going in the same direction as I2 is? See, I go from C to B. I2 is also in the same direction as CB is. Yes, yes, okay. Let me write first this one. Voltage of resistor 3 equal 0. Now let's complete it. R3. Okay. V2. Alright guys, I am here. You know, when you get professional, you don't need this section. You need just to write this part. Okay, BE, go. Go, 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 go. Oh, what is this one? Will be minus V1. V2, sorry. Because you meet second pole. Go, 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 nothing, nothing, nothing. Oh, okay, what is this one? Battery. You go from negative to positive, so that will be plus V3. Okay. Now watch. Go, 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 go. Oh, 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 what is this one? It's resistor. Ask this question. Hey, I go from C to B. Is the current also in the same direction as CB is? Yes. Am I going in the same direction as current is in that branch? Answer is yes. If yes, it's minus. If not, it's positive. I'll tell you that later, but first this one. If not, it's positive. That's all. So that will be R3 I2, because I2 goes through this branch, equals 0. Correct? These are important. Now guys, it's all, the rest is algebra. You can do also by your calculator using metrics. The students who they know about application of metrics, and you can solve, you can do sets by matrix way, by your calculator, will be very easy. But now I am going to write here. Watch, guys. Now you need to substitute R1. What is R1, guys? It's 1, negative 1. I1, it's I1. Just substitute. Minus, what is V2? It's 10. Correct? Minus R2. What is R2? It's 2. I1, I don't know. That I1, I2, I3, they are unknown value. What is V1? 20 equals 0, correct? Now, on the second one, minus V2, so I am going to have minus V2 is 10, correct? Plus, what is V3, guys? V3 is 5. Minus R3 is 3I2 equals 0. Oh, this is very simple. So, let me put this one here. Then, guys, here I can say actually what? Minus 1I1 minus 2I1, it's going to give me negative 3I1, correct? Negative 10 plus 20 is positive 10. Move it over will be what? Negative 10, correct? So by this one, I can find I1 is equal with 10 over 3 amp, which will be 3.33. Then by this equation, I can find I2. I2 will be, so this will be negative 3I2 equal. Negative 10 plus 5 is minus 5. Move it over will be 5. So I2 will be negative 5 over 3 amp. So far good. When you done, let me do by, what color do you like? Red? Okay, let's go by red. So what I am going to have, we found I1, we found I2 together. Now let's find I3, because I have I1 plus I2 is I3. Therefore, I3 becomes what? I1, which is 10 over 3, plus I2, which is minus 5 over 3. The answer is 10 over 10 minus 5 is 5 divided by 3 amp. So this is I3 becomes 5 over 3 amp. Of course, you can do by calculator. That will be 1.67. That will be negative 1 point. So this will be, let me write, this is 3.33 amp. This will be negative 1.667 amp, and also this one will be 1.67 amp, correct? Make sense? So this is how can we solve Kirchhoff's rules. So on the next page, I want to give you one problem, one example, and you have to do it as a quiz. You have to send it to me as a quiz, and due date is tomorrow is Tuesday. Due date is Wednesday night. Okay, I'll tell you. So question is, again, below circuit, find current goes through each resistor. Okay, yes, okay. So guys, I am going with this picture. Okay, let's call this one V1 is 10 volt. This is positive, this is negative. This is positive, this is negative. Let's call this one voltage 2 for battery 2 is 20 volt. This is positive, this is negative. Voltage 3 is, what do you want? How much? Let's choose it by 10 volt also, okay? So let's say R1 is 2 ohm. Let's pick this one. R2 is 4 ohm. Let's pick this one. R3 is 6 ohm. And R4 is 8 ohm. Okay? Now, I will give you currents. You go all with the same direction, with the same currents. So, again, it's up to you. You're completely free. But at this time, oops. I don't know why this line comes. Really. Okay. So, I'm going to say I picked this one as a I1. Okay. And then I picked this one as a I2. Okay. And you see I1 is this, I2 is this. So these are two input. They go, then they will flow. So let's pick this one, what? I3. Make sense? Now, due date. Now what you have to do, you have to label all corners, points, nodes, or junctions, A, B, C, D, E, F, G, H, maybe you have more. Then pick direction. For this one also pick direction. Any direction you want, it's up to you. Just remember, ask always this question. If you go in the same direction as current is, your voltage is negative IR, RI. If you go in opposite direction of current, your voltage is minus R times negative I. Don't forget this, which it will be positive RI. Did you get this? So if you go in the same direction, let's say yes, it's minus RI. If you go in the opposite direction, Are you going in the same direction? Let's say no, then it is this. Okay? It's paused for I. So remember that. So do this problem. Today is March 23rd. Tomorrow is 24th, 25th. So 03, 25th, 2020, correct? Until 7 p.m. Everybody, all four sections of physics 4B, they have to submit it by email. Please submit it into my canvas. Each course into the canvas, okay? Not on my email. It will come on my email, but please send it into canvas. Do not forget it. By canvas, send it by your email. So do it again. Please take the note. Write your notes. So assume it's exactly like our class. This is whiteboard. So whatever I say, write it in your note for yourself. Practice, practice, practice. I'll see you hopefully very soon. I'm going to put some labs online, and also during lab time I can do more problems for you. So we will be in touch. I love you. I hope you have a great time, great days, and all together we will overcome on this situation. Okay? Have a good night, good day, and I love you. Bye, guys.